Hi, my name is Rob Lillyholm. I'm an associate professor in the School of Forest Resources here at the University of Maine. And what I'd like to do is talk a little bit about some of the research we're doing in East Africa, in Kenya specifically, looking at alternative futures modeling in some wildlife areas. We focus on Kenya because, first of all, it has some of the most spectacular wildlife anywhere in the world. Globally, it shows up as one of the most diverse and important ecologically areas for especially savanna land animals. And altogether, these wildlife are not only an important part of kind of global biodiversity, but also a very important economic driver for Kenyans. Our particular focal area is in the southern part of Kenya, and we're really primarily looking at wildebeest. Wildebeest are particularly important because of their long migration, one of the largest land migrations of any large mammal, and they also form a key part of the food chain. If we focus on some of the more important wildlife refuges within Kenya, we see a number of growing pressures on these areas. First of all, we see urbanization, and here's a picture of downtown Nairobi. You can see it's in many ways a modern urban city. We also see, and this is what fuels a lot of that growth, a lot of mining. Also, what we're seeing is a lot of deforestation, fencing, and increased agricultural use of the land. And then also across this entire region of southern Kenya and into Tanzania, we're seeing changes in climate that are making the droughts and the rainy seasons a little less predictable. We've had some very severe droughts in recent years that have led to tens or even hundreds of thousands of deaths of different types of wildlife. Our project objective is to try to figure out how future development and climate change is going to affect the sustainability of wildlife populations and their migration patterns. We have three primary focus areas. The first is Nairobi National Park, the second is the Masai Mara National Reserve, and the third is Amboseli National Park. You can see in this map of Kenya, we're looking at the southern part of the country. Like most other national parks in this region of Africa, Nairobi National Park was set up to protect dry season habitat. These are permanent water sources. The idea was that during the dry season, animals could congregate in these national parks as a sanctuary, and then when the rains came, they could move out of the park. What's happened in recent years is that increased urbanization and conversion to agricultural uses has limited the ability of animals to get in and out of the park. This map shows Nairobi National Park, and to the north you can see the capital city of Nairobi. The narrow arrows leading in and out of the park show historic wildebeest migration routes that are no longer in effect because of urbanization and development. The thicker lines to the south show existing wildebeest migration patterns. The next slide shows some of the high density, these are actually some of the urban slums that are located just a few kilometers north of the national park. This happens to be the Kibera slum. In 2005, there were 2 cement factories in this region. Today there are 5, and they're busy fueling basically the growth of the city and outlying areas. This next slide shows some of the mining along a Riparian Corridor, and this is just on the south boundary of the park. There are laws in place to protect those riparian corridors. This shows a 100-meter buffer around the stream, but what's happening is the mining is going right up against the edge of that buffer. This creates almost like a Roman aqueduct, where we've got a raised stream bed with the areas all around it mined. Another threat to the park is increased fencing. Through time, as the landscape becomes more fragmented, more and more people are coming in, buying small plots and fencing the plots, sometimes putting in agriculture, sometimes not. All of these fences decrease the permeability or the ability of the animals to move in and out of Nairobi National Park. There are also some large homes that are going in along the southern edge of the national park. And then finally, this is kind of a shanty town that's sprang up on the south part of the national park. You can see wherever you get roads and power lines, pretty quickly you'll begin to see the beginning of a new settlement. If we move now to the Masai Mara National Reserve, there we don't see the overall development pressures that we see up around Nairobi, but we do see some deforestation going on, especially in the Mau River, which is critical as a water supply for the Mara River. We see increased fencing going on that once again is decreasing the ability of animals to move through that landscape and get to that dry season habitat. And then we're also seeing increased pressure for new ecotourism lodges and more visitors. a lot of times these lodges will go in right on the boundaries of the national park. So while we're not seeing the types of development that we see up in Nairobi, we are seeing a more constricted, kind of de facto chain around the national park. And sometimes these fences can be 12, 15 feet tall and electric to keep wildlife, whether it's predators or elephants, out of resort areas and swimming pools as well. Shifting our attention now to Amboseli National Park. Now we're in that southeastern area of our southern Kenyan study area. And here we see once again ecotourism pressures, new lodges and increased visitation. Then we're also seeing agricultural development, especially along the eastern edge of the national park. Now Amboseli sits at the base of Kilimanjaro, and it supports a lot of swamps and wildlife that rely on those swampy areas. Some of those areas outside the park are being readily converted for agricultural production. So getting back to the overall objective of our study, we're trying to use alternative futures modeling as a way to understand the past and then envision what the future might look like. We have two main components to the project. The first is modeling wildebeest migration behavior, and we're doing that using hourly GPS tracking from radio collars that are on about close to 40 wildebeest. And then those data are being uploaded via satellite and used to create agent-based models that predict individual wildebeest behavior. The second part, then, is to create future landscapes based on past and current development patterns, and then try to understand how these new landscapes and wildebeest behavior interact through time and see what that implies for the viability of wildebeest and other wildlife to be able to survive under changing human and climate conditions.